This is Miss Goodale, and I'm doing a second part to comparing fractions and decimals. This time I'm going to talk about comparing and ordering when you have both fractions and decimals. For example, if I were given this list of fractions and decimals, so 2/5, 425 thousandths, 3/4, and 625 thousandths. The first thing I want to do is to make them all the same. Either I'm going to convert all of them to fractions and then compare, or I can convert them all to decimals and compare. That's usually the easiest way. Sometimes it's easier just to compare a few, but just for generally, I'm going to change them all to the same thing. And what I find the easiest is to change them from fractions to decimals. So that's what I'm going to do in this video. So I'm going to take my 2/5, and remember to change 2/5 from a fraction into a decimal. I would put my 2 on the inside of the division box and my 5 on the outside. And 5 will not go into 2, so I'll put a decimal. And it will go into 20, which is 4 times. 5 times 4 is 20. I subtract and get 0. So my 2/5 is actually the same thing as 4/10. And I would just write the number right above my other number just to keep track of what it actually is. So then my next thing I would do is change my 3/4 into a decimal, okay? So I'm going to put my 3 on the inside, that's my top number or my numerator, and my 4 on the outside. 4 does not go into 3, so I'm going to put a 0 and then a decimal and a 0. And 4 will go into 30. It will go in 7 times. And 4 times 7 is 28. If I subtract, I get 2. And then, since I have a number down here, I'm adding a 0 to keep going. So I bring that 0 down. And 4 goes into 20 evenly, which is 5 times. So 4 times 5 is 20. And this 3/4 is equal to 75 hundredths. So now that I see that they are all the same, I can easily compare. So I'm going to draw squiggly lines here, and I'm going to go again from least to greatest. One thing that you need to make sure that you do every time you do problems like this is pay attention to whether it's saying least to greatest or greatest to least, because sometimes students get tricked on that. So my least to greatest, I'm going to look for from left to right. All of them have a 0 in the ones place. Then I look at the tenth place, and we have 4, 7, and 6. The 4 is the smallest, so we have 4/10 and 425 thousandths. This one, 4/10 is the same thing as 400 thousandths, and 425 thousandths is obviously comparable. If we compared it from left to right, then we would compare 4 to 4, 0 to 2. 0 is smaller, so this one is actually the smallest, and that would be 2/5. And I could probably just write a number 1 here just to keep track. My second smallest is this one, which is 425 thousandths. And then my next one starts with a 6, so that's 625 thousandths. And then my last one, 75 hundredths, which is 3/4. Again, just like I said in the last video, notice that I am writing them in the original form. Even though I changed them in order to compare, I put them in their original form in my answer because that is what I will be looking for. Let's do an example of just comparing two numbers. So for instance, 6/8, and I'm going to compare that to 0.6, or you would say it as 6/10. I could compare by changing either one. For me, my 6/10, I know in my head this is like 6/10. And if I know 6/8 and 6/10, well, 6 pieces out of 8 pieces, the pieces are going to be bigger. So I could do that, and that would be a way to compare. If I did it the other way and I compared, and this is going to be kind of the same thing, only a different, I'm going to write it again just to show you that this is not the same way to compare, it's just a different way to do the same thing. I can do the division again. And 8 does not go into 6, but it will go into 60. 8 times 7 is 56. And you subtract, you get 4. Since I have something left over and it's a decimal, I can add another 0. Bring down my 0, it's 40. 8 will go into 40 5 times. 8 times 5 is 40. Subtract and I get 0. So 6/8 is equal to 75 hundredths. And if I look at the numbers, 6/10 and 7/10, I know 7 is bigger than 6. I compare from left to right, remember. So that one is also bigger. Another way you could look at it is if you changed this to a fraction and then made the denominators the same. So 8 and 10, they both go into 40. So we could do 6/8. 8 times 5 is 40. 6 times 5 is 30. So this one is equal to 30 over 40. 6/10, and I'm running out of space here, but we can make that into 40ths. 10 times 4, 6 times 4 is 24. Okay, and then I could compare 30 is bigger than 24. So that's actually 3 different ways I could have done that one problem. I could have done it by just making this into 6/10 and knowing since the numerators are the same, that I can compare. I could have done them by finding a like denominator and then comparing the top number, the numerator, or I could have compared them by changing my fraction to a decimal. Okay, so let's come up with another example for each type. Let's do another comparison example first. And you'll notice most of the time I prefer to change my fractions to decimals just because a lot of times it's easier. Sometimes my decimals do not come out evenly when I do that, but most of the time it gives me a pretty good idea. So 9 will not go into 1, but it will go into 10 one time. And I have a leftover 1, so I would put a 0. 10, and this is one where I'm going to notice I will get a repeating decimal.